nine sections in chapter 1, but we're here, final section, and it's about zero and negative exponents. I've been kind of building to this, at least in the videos. Maybe I'm probably in class. I've made it a point to kind of foreshadow how I'm eventually going to teach you how to deal with negative exponents. But also, what does it mean to have a zero as an exponent? I think I've also mentioned that once or twice, at least in the videos. So let's officially do this section. Once again, just kind of a flashback, I guess, like taking one step back so we can take a few steps forward. Remember that when you do 10 to the 8th over 10 to the 6th and the bases are the same, you end up basically, because of everything that happens behind the scenes here, you end up just subtracting the powers. And so likewise here, 10 to this power over 10 to the first power, this is what's going on, and you end up canceling and stuff, and basically just, at the end of the day, subtracting the powers. So that's a little quick reminder. But now think about this stuff. All right? If you had, for example, 10 to the 4th over 10 to the 6th, look what happens behind the scenes. And then as far as like canceling goes, like those two 10s could pair up to divide to 1. These two 10s could cancel each other out and divide to be 1. These two 10s, right? These two 10s. And then that would be all the canceling that would happen. And so what you would get, and I guess I'm going to go over here at first, you would have two factors of 10 as sole survivors, or dual survivors, I don't know, sorry, as the survivors, but they happen to be in the denominator. So you'd have a 10 squared. Ah, that's no good. You'd have a 10 squared, but it'd be in the denominator, right? And then what would be on top? Well, just 1, okay? Technically 1 times 1 times 1 times 1, you know, but so in a way your answer is 1 over 10 squared, but the shortcut that we just got done mentioning a couple minutes ago, if you do this top power minus minus that bottom power, and you know, subtract the powers like the shortcut is, you would get what? 10 to the, what's 4 minus 6? Negative 2. So if you do the shortcut, you get this. If you do the, you know, expanding it out and canceling, you get this. Well, guess what, people? They are equivalent. They mean the same thing. This is essentially the same as this. And that's going to be a really, that's going to pretty much tell the story of how we deal. It's a little bit of a way to look at how we're going to deal with negative powers. You know, this is a negative power, but there's no negative power here, and this means the same as this. Another quick example is that if you just subtract these powers, okay, here, you end up getting 10 to the negative 5 power. But if you just cancel what can be canceled, look, you end up with 5 surviving factors of 10, but in the denominator they're survivors, you know. Then the numerator basically becomes 1, you know, because, right? So 10 to the negative 5th power is equivalent to 1 over 10 to the positive 5th power. Again, it kind of like gives you at least a hint about how we're going to deal with negative powers, because this means the same as this. You know, in other words, like, in case you haven't, you know, picked up on what I'm putting down, if you smell what I'm cooking, we're gonna like this a lot better than a negative power. So, like an official property or an official rule that you might see in a textbook, if you have a negative power, x to the negative m power, you could rewrite it as 1 over x to the positive m power. In other words, I'm going to probably say this a lot. In order to make, so ready? Let me pause for a second, because this is huge. You ready? So, in order to make a negative power into a positive power, move it down to the denominator. You could think of it having an elevator, like take this, which right now is technically in the numerator, like this is technically a numerator, over 1, right? Move this base, take the elevator down to the denominator, and the negative power will turn positive. And that's basically how you deal with negative powers. Okay? So here we go, some examples. Let's go bison blue. The first thing I would do here, like you could deal with this being a negative power, and you could like change that as the first thing you do. But actually what I'm going to do first instead, it's not more correct or anything, just what I prefer personally. I'm going to multiply this x, which is technically a 1 power, and I'm going to do x to the first times x to the negative 13th. What do you do with the powers in this situation? Do you remember? You should. You add the powers. And when you add those powers, you end up with x to the negative 12 power. Now, the directions, maybe I should have read this out at first or whatever, but what the? Another chance for bonus points? If you catch that in class before I do, I wonder if that happens. Anyway, write your answer in exponential notation with positive exponents. So this negative exponent is no good. So how do we make it positive? We drop it down to the denominator, and the numerator would be 1. Okay? Number 2, very similar. Let's do these x's, or this x to a power times this x to this power, and then same thing with the y's. I'm going to make this, and remember, you'd add the powers, and so 3 plus a negative 2 is 1. And I don't need to write that up, but this isn't my final answer anyway, probably. So anyway, but x to the first, and then y to the 8th times y to the negative 10. You also add the powers like we've been doing for a few sections now. And what's 8 plus negative 10? Negative 2. And so, hey, we have a negative power, which is not a-okay for a final answer. So what we're going to do is drop the base y down to the denominator, but just the y. The x has a positive power. That's good, and that can stay in the numerator. Okay, we only bring the y down because that's the only thing that has the negative power. X doesn't have a negative power, so the x is good where it is. But the y comes down to the denominator, and the negative 2 becomes positive 2. All right? And that would be a final answer. Can't do anything more simplifying wise. Number 3, what do you think we should do first? Well, we have x to some power over x to another power, so it's the same base, and so we can do what with the powers? Subtract. 7, top power, minus 9, the bottom power, to get negative 2 power, which we would rewrite, and we would drop the x down to the denominator and to make the power positive instead. Simple. Over here, likewise, I'm going to these will simplify with each other, and again, we would just subtract the powers, and then same with the y's. And so 3 minus 2 is 1 technically. I don't really need it there because it's a 1, but I'm probably not done anyways. 8 minus 10 is negative 2. So, wow, this is going to be the same answer as number 2, because the x will stay where it's at, but the y drops down. Okay, so the x stays in the numerator, x to the first power, and only the y drops down to make the negative power positive. More examples. We're just combining everything together now, aren't we? So do you remember what happens here? What I'm going to do first probably is, yeah, I mean, there's other things you could do first. You could deal with the fact that this power is negative or that this power is negative and turn them positive as your first moves. But what I'm going to do is just kind of apply this power. I don't care that it's negative right now. I'm just going to apply this power to the x squared, the y to the negative 3 power, and the z to the 4th. And it's always going to be power to a power, power to a power, power to a power, which means I'm going to multiply all that stuff. So it's going to be, what's 2 times negative 6? Negative 12. What's negative 3 times negative 6? Well, that's positive 18. And then what's 4 times negative 6? Well, sir, that's negative 24, I do declare. And now to finish this up, I just need to address, how we have a couple, not just one, but 2 powers that are negative. So the y to the 18th can stay in the numerator because that has a positive power. But the x comes down to the denominator, takes the elevator to make that power positive, and the z drops down to the denominator using the elevator, the fraction elevator, never out of order. Sorry, bad pun. To make the negative 24 into a positive 24. Let's move on to number 6. Same deal. We're going to raise, don't forget to raise numbers like 8 to the 5th power, because the 5 applies to the 8, which again, technically the first. But then we have a power to a power, because the 5 also comes here. And we get negative 20 when we multiply those powers. Now the 8 to the 5th stays in the numerator. That's a positive power. That doesn't move. But the x comes down in the elevator to make the negative 20 into a positive 20. And that, once again, I know 8 to the 5th is something, some big number, but did the directions actually say, yep, leave it in exponential notation. So leave it with its exponent there. And just leave it as is with an exponent. What about these? Well, what happens here, okay? We are changing gears, so take a breath, So what happens? On one hand, it's like we have, if we were to just subtract the powers like we've been sort of groomed to do, what's 4 minus 4? Well, that would be 0. We would end up with 10 to the 0 power. But if you look at it as far as like from an approach of canceling, and how these 10s divide out to be 1, and these 10s divide out, and these 10s divide out, and these 10s, there's like no factors of 10 left over, and what you're really left with is like, technically we'd say that these are also, but it would be like 1 times 1 times 1 times 1 on top, and 1 times 1. Basically, at the end of the day, it's just going to be 1. I hope you see how that's true, how like when all these cancel out, and you think of like canceling, you end up getting 1. I mean, okay, think of it this way, If you had just 6 over 6, which means 6 divided by 6. What's 6 divided by 6? That's right, 1. What's 11 divided by 11? You know, when you have the exact same thing up here as down here and you're dividing, you get 1. Like, what's x divided by x? 1. What's 20 divided by 20? 1. Well, if this is exactly the same as this, it makes sense you're going to get 1. But anyway, in another way, we got 10 to the 0 power. And let's do one more quick one, right? Once again, if you subtract the powers down here, in a way you end up with 10 to the 0 because that's what 7 minus 7 is. But again, when you do all the canceling and there's no survivors and everything kind of divides out to be a bunch of 1s, right? So it's like, wait a minute. If you raise 10 to the 0 power, you get 1? Like they're the same? Yeah, they are. And it goes even deeper than that. Anything to the 0 power. Like this x could be anything. 5 to the 0 power. 10 to the 0 power. X to the 0 power. Z to the 0 power. 1 million to the 0 power. You get 1. So anything to the 0 power. Well, if you ever get to calculus, you'll learn that not everything to the 0 power is 1. But for now, whatever, anything to the 0 power is 1. So let's see that in action a little bit, right? I think just 4 quick examples, which, you know. Now look, when I say anything to the 0 power, even a bubble with x, y, and z in there, or just x, y, z, it's just going to be 1. Okay, now if you wanted to, okay, in another way, if you wanted to do x to the 0, y to the 0, or like y to the first, you know, x to the first, y to the first, z to the first, all to the 0, whatever, you get that. But isn't this 1 times 1 times 1? So either way, it's just going to be 1 at the end of the day, right? So final answer is 1. No matter what. Number 2, what you're going to do, like, what do you do in this situation when it's like base to a power times the same base to a power? What do you do with the powers? Do you add them, multiplying, subtract them? What do you do? You add them. So what's 13 plus negative 13? 0. And so do we stop at x to the 0 power? No. Anything to the 0 power is 1. So the final answer is 1. Anything to the 0 power is 1. Okay? Can't say that enough. What are we going to do in number 3 first? I would do this power of 4 to this bubble. So it'd be like power to a power, and then technically power to a power. X to the 8th just kind of copies, and then power to a power we get negative 8, and then y to the 4th, or y to the 1st to the 4th. Look at that. Now to do this, we're going to add the powers and get 0, bring down the y to the 4th. Now this is just going to be 1. So it's going to be 1 y to the 4th. Don't need to write the 1 in this situation. So final answer, y to the 4th. Looks like number 4 is really similar. Again, I don't care if this is negative or positive. You know, I can deal with the negative powers later. I mean, you could do it right away, like I said before. You could change this to a positive power by doing the thing, or this negative. But I usually like to deal with negative powers at the way end. That's just my preference. So anyway, let's just apply this power to x to the negative 2, and also y. Bring down the x to the 10. So power to a power, what do? You multiply the powers. What's negative 2 times negative 5? That's positive 10. And then y to the negative 5 is y to the negative 5. And yeah. So hopefully you notice that you can multiply this together to simplify, Remember, you want a simplified answer, as simplified a final answer as possible. And so what do you do here to simplify? You add the powers. And are we done yet? No, because can't really have a negative power. And don't really, even if the directions don't actually say it, you still should almost always go by that, And so we're going to have the y base take the elevator down, but the x to the 20th stays in the numerator. And bam. Okay, because in a way, just to kind of maybe, I don't know, give a little bit more thorough, in a way, like I said before, this, x to the 20th, y to the negative 5th, right now this is in the numerator, because if you wanted to make this into a fraction, you'd put it over 1, where 1 was in the denominator and this stuff was in the numerator. So once again, this stuff is technically in a numerator, which means x to the 20th stays in the numerator. That's why I say it that way, that it stays in the numerator. But the y takes the elevator down to the denominator. Okay? I think that's it for that. Freedom!